All right, music.
You're on camera.
Yeah. All right. Let me start this thing up. Hold a second. Got to turn off the banner. All right. There we go. All right. And we're live. Let's go ahead and turn off this thing. All right. So, welcome to another episode of devOSH Live. This is, I don't know, the 10th or 11th episode. So we had a day off last week because I had visitors in town, but we wanted to get back and see what's going on with our projects and kind of see where we're at and see what's coming up. Our co-host Fixer Robert is not going to be here this week. He's off in London for a conference. So it's just going to be me and Kevin today. And to go along with the rest of the episodes that we've had, we're going to go ahead and talk about the Maker Chip Plus, I guess we're calling it now. So that'll be the first topic. And then I'd like to, I guess, talk about the start of the next project. The voting process is over now. So, and we'll discuss the winner of the process and then kind of next steps. And we can start doing some design work here on the call for a good, fun, collaborative time. All right. So before we start, you'll notice the GitHub page that's scrolling across the bottom there. That's where you go to collaborate with us. And if you're interested in open hardware and want an outlet for developing open hardware, this is it. So if you go to that repository, you'll see it's a gathering of minds to create open hardware projects in a collaborative fashion. If you have an open hardware project that you'd like to talk about, you can go ahead and create a ticket there or contact me. I'm on Discord, and you can just join the devECO Discord and let me know. And if you don't want to do that, there's also a devECO.io page that we have. So that would be this guy, devECO.io /hub/devOSH. So that's kind of a project hub for everybody to join. And I have a copy of that up so you guys can see it. So if you want, you can start discussions right here on the devECO IO hub for devOSH, and you can kind of open up the discussion here as well. I think this is a good starting point, and it's a good place to kind of plan and also show off your projects once they're ready. So I'd like for people to kind of have a easy to access way to collaborate, and this is kind of the central hub for doing that. And you'll see like the previous projects, like the Bevy LED badge. We don't have I don't know if we have one for the Maker Chip project yet. I think that's in the works eventually, but that definitely is coming. So that's kind of where everybody kind of joins and kind of discusses the projects, and we can do chat through this as well. The sign up is really easy for this, and if you have any questions, like you can go ahead and ask them in the chat. But yeah, this is pretty much the start of the hub on devEco.io, so that we can collaborate there. But there's also just going directly to the GitHub page, and you can add an issue here. If you wanted to, say, come onto the show and show off open hardware project that you've already worked on, then you can just add a new issue and kind of explain, okay, I'd like to be on the next episode or on one of the episodes eventually. I'd like to set up a calendar eventually, but it's kind of hasn't been done yet. Yeah, so that kind of gives you the kind of the short, long version of kind of where we're at. So I'd like to now kind of hand it over to Kevin to present about the MakerChip project and kind of the current status. So do you have any thing to share, a screen share or anything that you'd like to share? If so, you can add them now. Looks like you're muted. Is the audio not working for you? Can you hear me, Kevin? Are you out there? Looks like he's having audio issues, maybe. I'm not sure what's going on. So let's see what we got going on here. Okay, Kevin, are you able to? Oh, he looks like he jumped. Okay, so not to leave some dead air, instead of going on to the MakerChip project first, we can talk about the next project that was selected to be the next project based on votes. So the polling process isn't great yet, but I used a simple Discord poll to ask people that are in the Discord what they'd like to do next. And that was based on the numerous issues that I created here. And as you can see, there's one marked as the most votes. And I guess since there hasn't been any votes, the FPGA reference design is our next topic for creating a new design. So this I'd like to keep it an open hardware, of course, project, but also I'd like to use the open source tool chain. So that would be a nice 40 or ECB5. There are a few others. The Project iStorm Trellis was a effort to reverse engineer the bit streams on Lattice FPGAs that were the first ones on the scene. ICE40 was the first. And So I have a design that I worked on with previous guest Eric Brombo, and this one I'd like maybe to follow kind of the same form factor if I can, but maybe mix it up a little bit so we can have something new and exciting. So I can show everybody the the design of the Ice 5 wireless real quick, so you can see what I'm referring to. Um, I actually have one of the boards here. It's actually an end enclosure, but this was a design that I worked on with in collaboration with Eric, and it is a small FPGA board that has a nice 40 plus ESP32 C3 wireless microcontroller, and that I'd like to try to keep the form factor if I can. So maybe we can make a derivative of this that maybe uses the ECP5. The ECP5 would be kind of maybe a step up in terms of lookup table count. There are advantages to the ICE40. There's a lot of SRAM in there, and it is probably the best supported FPGA in the open toolchain domain. But we may or may not use ECP5. I have kind of a feeling that if we want to make more complex designs, that we'd probably want to bump up to the ECP5. And I think that we'll just probably go with that for the design. So the ECP5 is a lattice FPGA. And there are quite a few designs out there. And there are a few open hardware ones that I actually helped and collaborated with other people on. But the most popular one is probably the ULX 3S, which is a nice little dev board. Is the ECP5. This one actually includes an ESP32, and it has added an FTDI for programming, RAM, external RAM in Flash, an SD slot, lots of cool stuff. That's a very useful board. It's very popular. This one is open hardware, so you can find this design and actually make derivatives of it fairly easily. It's pretty popular. One of the earlier ones on the scene, but there's also the Orange Crab, which was done by Craig Tavel. This is a very nice board. Let's see if we can get something about it up here. And all of these have Orange Crab is open hardware as well. Actually helped with the test fixture for this and some of the testing infrastructure. Let's add Kevin back to the stage. Are you out there, Kevin?
Hey, can y'all hear me?
Finally, you're back. All right. What happened?
Hey, sorry, I honestly don't know. My end just froze up completely and crashed on me. So I had to restart my computer. Everything started to bind up. So I sorry about that. I actually had everything pulled up and ready to go, and left you hanging there. So
fine.
My apologies.
I actually carried on so as to not leave dead air, and I can go ahead and finish up what I'm presenting, and then we can go back to the maker chip in the second half of the show.
Yeah, absolutely.
Good?
I will say that that's great. Let's definitely do that. I will say that I did leave my charger at work today, and so I will present when you're done. I will present as long as I can. It is a minor update, not nothing too major,
Okay.
but I'll definitely get a chance to talk about it.
Okay. Okay. Cool. Yeah, and yeah, I should be done pretty soon here. I'm just kind of going over kind of the ECP5 designs because I all right. So yeah, I'm going over the open hardware designs based on ECP5 right now, and just the ones that I know. The Orange Crab is kind of special. I actually helped design the test fixture for this and helped with the crowdfunding campaign for this. And it's a nice board. I think it's maybe end of life now. I don't know. We can check that actually. Looks like no. Let's see if we can buy them still. Out of stock at 1 bit squared. So yeah, we had them out of stock. Yeah, I think that they're pretty much out of stock everywhere. I think that they're no longer being made. It was a crowdfunding campaign on group kits, and I work with them quite a bit. So that one was fun. There's also from Greg. There's the butter stick FPGA, which was another one that Greg created. Is another good reference, and it has a lot of examples. But the hardware here is all open and it's available. So there's another one we can use as a reference. All these are using the BGA, which I may or may not want to use. I really want to make this something I can actually assemble at home easily. And FPGAs it can be tough sometimes. But yeah, this is a nice reference design. It has a bunch of different things. So I'm gonna go ahead and grab a hold of this and put it in here. And we'll grab the link for the Orange Crab as well. And that one, I'll grab a hold for that one and put it in here. And let's see, the ULX, I'm guessing, let's go find the ULX 3S. There we go. Okay. Yeah. And then we can grab the design files for this. So we have another reference. Nice little reference. All right, and I think there's one more that I've seen that was maybe a little easier to do at home. Was a board that Matt Venn worked on, and I don't know if I had like a link to that one. I think it was a ECP5, but it was a quad flat pack, which would be easier to assemble. Let's see if we can find it. If you don't know who Matt Venn is, he's a kind of famous for the open ASIC course. He does 0 to ASIC and the Tiny Tape Out, which is a service that was created to let people design chips and not pay a ton for them. So here's another design that I can have for reference. This is an ECP5 design that's a little easier on the, oh no, this one is also a BGA. Okay, well, it's another design that we can have for reference. So apparently there's a lot of them out there, but you know, what's another one? And we can make something different about it that makes it special. We'll add. I'm thinking probably I'd like to use, instead of the ESP32 regular, maybe using ESP32 S3. Because I think that would be fun, and it's a little more peppy than the C3, and that way we can maybe do some interesting applications with that. If not wireless, we could probably do maybe an STM32. That would be kind of cool, and it would make the check boxes for another project. But we don't need a microcontroller to program the FPGA. It would be nice, and you can also avoid having to put a complex microcontroller into the FPGA, which will eat up the resources. So I'm going to kind of figure out which microcontroller I want to use, but these are kind of my top choices right now. And I think beyond that, we're going to do PMOD. I try to keep the ICE5 wireless form factor. That would be good. And it means we're going to have 3x PMOD. And USB-C. And it also has a LiPo battery management, which I can use that design as a reference for that. So for that, the ICE5, I also have the design up here. So this is the board. And we'd have the 3 PMODs, USB here, battery. I might change the battery to the bottom. I don't know. This was kind of difficult when we made the case, because you'll see that it kind of comes out the side and then feeds back in. If we would have had the connector on the bottom side, it would have just been able to kind of feed into the bottom of the enclosure. It would be nice to be able to use the same enclosure or a similar one. I'd like to be able to, maybe we could make it a little bigger, but I'd like to maybe try to keep the form factor. It might be tough with ECP5 because of the size of the device. So if we have to go wider, I would assume we would grow it. We would grow down. So like from here, we could maybe add, and then we can modify the case pretty easily. All the designs for that are open, and I was actually designed by Griffin from Group Kits, the case, and it was really nice. It's got these nice buttons on there that are actually built into the case, and I really like these buttons. Very nice.
Nice and clicky.
Yeah,
hey, Michael, I've got somebody texting me to check the comments. Do we have any questions in the comments?
Oh, wow. Yeah, I guess we should. Hello. Oh, hybrid's on. So yeah, we're getting into the project, the next project. So it's going to be FPGA, because that's the one that won the votes. And yeah, hopefully everybody's going to be super happy about it. Looks like we got a question from Mark. show this one. So yeah, so are there any FPGA boards that do OTA bitstream updates? Well, it's possible with ICE5 wireless, and it's not like it is exactly kind of like the idea is to be able to update the bitstream remotely, and we actually have a lot of the firmware worked out for that. It uses ESP32, whatever they call it, ISP, their platform. And yeah, it's not perfect, and it probably could, the firmware could probably use a little bit of love, but you definitely can do that. And that was one of the ideas. So yeah, that's definitely in the realm of possibility. OTA should be really neat. So let me go ahead and save the changes that I created to the GitHub repository really quick, or at least the ticket. Since we're about halfway through the show, it's almost time for Kevin to jump up and talk about MakerChip. So I'll continue to work on this, and I'm actually going to create a page on devOSH here, which will have the kind of the same information and links back to the repository and kind of all the design things that come into play, and that way we can have a collaboration point outside of GitHub if people are wanting that. I think it's good to have kind of a place to show off the project, though a lot of the times you can just kind of build it into the README, and like all the different stuff can be right in the project with markdown files, etc. But I do like the idea of using the devOSH for the project, and I will create a page for that. So that's the next project, and hopefully it goes well. We'll see what happens, and yeah, if anybody has any, anybody has any final comments about the FPGA project, now's the time. It looks like Jeremy over on YouTube was asking, in the realm of possibility. Oh, it's definitely possible. It's actually, we've already proven that it works. It's just not super secure yet. So if you don't care that your bitstream is flying through the air without any encryption, then it's okay what we have.
So over the air, are we primarily thinking updates? Are we primarily thinking like what would be the main use case for OTA for an FPGA?
Oh well, yeah, I think you could dynamically change the bit stream, like depending on like the needs. I think it's going to end up being more of a dev tool than like a specific application for this board. So you could easily program the board with your new design and test it without like actually having a wired connection. But also, I think it would just like having that the FPGA bitstream, like if it was an end application, but you also found there's like a hardware bug in your bitstream, and you want to be able to change it out in the field. Say it was like at the top of a building or somewhere out on a limb where you couldn't get to it so easily, but you can connect to it wirelessly. Then you can just, connect in, change the bit stream, hardware changes, and everybody's happy. but yeah, it's going to be a fun project, and I'll definitely keep everybody up to date on it. And
I'm excited about the FPGA project. Just honestly, as a witness,
yeah,
a bystander, observer. I don't think witness is the right vocab there, but we'll use it for
I think
now.
it's a good learning tool, and I think that what I'll kind of make it like, hey, okay, now that we have an FPGA, what do we do with it? And like I can give some kind of tutorials on how to use it, how to make like a new hardware design using Verilog or whatever, and loading it up and showing people how to blink LEDs at first, and then maybe how to make a simple state machine, just adding like combinational or sequential logic. If you wanted to, you can get to like making a microcontroller in the FPGA, and you could also use it as like an extended peripheral interface. So you could add custom peripherals that aren't so easy to get with like your regular ESP32S3. So, or you could have it do a lot of different things. I actually, with this guy, I made it run the Nintendo emulation. So it actually got it to run with the without the ESP32, but actually like a Nintendo like core inside of the FPGA. I was able to run Nintendo games on this with a PMOD connected that was for like connecting to an HDMI or DVI screen. It's kind of fun. And there's a whole lot of things you can do with FPGA. It could be like hundreds, thousands of projects that we could come up with. And
you got to be careful there. This is a live stream. You don't want Nintendo coming after you for making an emulator here.
Well,
not really.
Making an emulator is really cool. It's making it's selling like the games, or taking the ROMs and distributing them. So like, I think I didn't make the IP, I just built it. So I don't know that I'm in any kind of legal.
No, I don't think so.
Plus, it's like a Nintendo NES, which is from like the 80s. So I don't think they're really worried about that so much.
I don't know. Nintendo and Disney are on the same level. I think there's more lawyers at those companies than there are actual humans working. So you'd be surprised. No, I think that's just a standing joke here, but no, you still have not satisfied my itch of the question, Michael. So you've described several examples and several applications that FPGA can be used for, but I'm a mechanical engineer, so this is beyond my typical realm of or my scope of knowledge. So when I think of FPGA, I think of sci-fi movies where they take out a chip and they're like, I got to reprogram it, and they put it in somewhere else. And they're like, all right, we're ready to go. Like, that's what I imagine FPGA is being able to do. But in reality, like, why would you use an FPGA over a microcontroller? Because the examples you've described so far are sometimes more efficient and fully capable with a traditional microcontroller. And over-the-air updates, sure, like adjusting the hardware, but you can't magically materialize a new motor on a drone with an FPGA. So why would you choose that over
you can
a traditional microcontroller?
The hardware behind the motor. So like, say you came up with a new driver like scheme for your motor. Say you wanted to update the micro stepping on like a stepper motor controller that's in the FPGA. You could actually change the hardware algorithm inside of the FPGA to do a little more granular control or something like that. Say you found that it like has some weird bug if you go from like, and your hardware is not quite right. and your drone like kind of like has a weird like dip in like the direction or something. Either way, it's just like you can change it, but it's like, yeah, there's always ways of doing things without an FPGA. You can use a microcontroller for nearly everything that you can imagine, but FPGA really kind of shines where it's something that you can't easily get it off the shelf, or it's like a custom control circuitry that needs to have like a kind of a fancy state machine behind it. And yeah, like if you wanted to be able to change that, like if you made the design and you can't really afford to do like a full custom chip, you can a lot of times drop in an FPGA and make your custom hardware that drive this custom, like say it was a rig that was like that had a lot of actuators, and you didn't have a chip that actually could drive all the actuators, but you could, daisy chain to the FPGA and say like, hey, make all these interfaces for me, and kind of go from there. It's really the use case of FPGA is usually a lot like a really something very specific that you need that you can't easily get from like a regular microcontroller off the shelf.
No, I think you made a great point. I think that one satisfies. So hypothetically, I may be shooting in the dark here, but hypothetically, if I had a board that had, I don't know, 4 FPGA chips on it, and I had a bunch of motors connected to it, and I all of a sudden I had to switch out one of the motors, but realized that the motor driver is not on the chip itself, because I have what, like, air quotes, FPGA chips on board. Then I can essentially reprogram that FPGA to act as my driver for the new motor component.
Yeah.
Okay.
Yeah.
I see. Okay. That definitely puts a little bit more perspective for me. Because I knew it wasn't, it's not sci-fi technology. They've been doing FPGA for a while, but I never really understood like the benefits of putting the extra effort behind having to go through that. But honestly, that instance alone would warrant some additional ones for sure.
Yeah. Dale had the idea of building a robot, and this is something that I've been kind of wanting to do since like college. I actually worked on a robot using FPGA, and of course, everything is more difficult if you have to start from scratch. You don't have an MCU. You have to kind of build one. It makes it a little more difficult. But then, like creating PWMs is like super simple. Creating like a simple stepper controller would be pretty easy to do in Verilog, and you can actually dynamically like change the pins to be for a specific type of motor or whatever you need. And of course, you'll need the drivers behind it, but there's digital I/O that needs to drive in a specific fashion to do the actuators or sensors or whatever you need. And a lot of the kind of the benefits of having an FPGA would be like, okay, I got a sensor I can plug onto that thing, and that FPGA could continually pull the sensor without loading down the main processor, so that it can kind of focus on the very specific task, or even do basic signal conditioning or DSP type tasks. And FPGAs are used a lot for oscilloscopes actually, and like high-end analog stuff, like just because the converters need to have something that's kind of taking the data off of them and like really fast, and it's got to go like straight to like cache memory, and you can't like a regular processor, general purpose processor is not geared for it. So there's a lot of things that FPGAs kind of shine at, but it's usually like very specific tasks. So yeah, this is the kind of stuff that you can do.
Yeah.
Make your rotary encoders, end stops, different things like that, that would like kind of have fail safes and things that would be hardware controlled. So there's like a deterministic factor to it that it's hard to get with software. So like control, I didn't do that on purpose. Yeah, so yeah, there's a lot of things you can do with it, and I think what one of our first projects will probably be kind of, hey, let's make a robot out of it, essentially, because it seems like we've been kind of dancing around it for a while, and we may as well, you know what I mean?
Yeah.
So,
Yeah. No, I'm all down for it.
yeah,
Since we've done the voting now, we can go ahead and do a couple design sessions on stream. So I'm actually excited for
yeah,
it.
yeah. So I guess we should probably get to the maker chip before we close out the hour.
Yeah. So
Do you have a screen
I've got.
share that you can pop up?
I do. I've got about 10, 12 minutes of battery life left here, so I'm going to try to breeze through it here a little bit. But I can definitely share my screen.
All right. Yeah, I think that, yeah, running on no battery.
Oh yeah, my computer alone is already rough on battery life because it's a little bit older computer, so the battery has gone through its paces. But then I went ahead and was in a rush today to get home and forgot my charger, so
Whoops.
it did not make it easy for me today to stick around. And the funny thing is, so I've got my computer set up where I get higher performance when I'm plugged into power. And just because it's an older GPU, older CPU, and some things it struggles with, so I tend to just run it on high power, and I'm usually always plugged in. It's almost like a monitor or a desktop setup. But so when I don't have my charger, it completely decimates all of the processing power. And probably probably multiple, but one of the reasons why I crashed earlier was probably because of it. So, all right. I'll quit wasting my time then and kind of jump into it. So, so I call it the MakerChip Plus because there's more than just one version of it. 2.0, 3.0, 4.0, whatever branch, whatever version that you're building. So I just kind of locally, just by myself, started calling it Plus because I was tired of explaining to people which version I was working on. So this way, kind of brings it all together. But I actually finished the PCB build this time around.
Okay. Ooh.
So I've been playing around with a TS circuit. And really, it was a challenge for me to try to figure out how to get all of the tools available to me working for this project specifically. And honestly, it was very, very difficult because there is so many times where I just wanted to go in there and make a really quick change manually to that I could have done so much faster. And I think that's one of the caveats here with working with open source and early development softwares is there's a lot of troubleshooting that you have to go through and a lot of patience. But I wanted to see exactly what it would take, like every single detail, every line of code that I had to manually adjust to kind of come to this output. And it really taught me a lot more about how the overall PCB design process works and how I can do a lot better job of building my projects to fit within the capabilities of the platform. And so this is the MakerChip 3.0, specifically designed for our magnetic system. Oh, there's my low battery alert.
Okay.
So all right. So I want to show it to you. So I've got my keep away areas here. I've got my AT Tiny chip at the top.
Good.
And then I've got the traces coming through the board, the vias, and as well as these edges. These it can't display it in the model, but they are supposed to be soldered edges, like actual copper on the edges there.
Okay.
And then I've got my middle section here, and it takes a second to load. And so the same thing, but this is just cutouts for the actual components. So the AT Tiny and the little cutouts for the resistors going for the LEDs, and then the cutouts for the magnets.
Very cool.
I keep the edges for soldering everything together at the end. And then the final top layer of the PCB.
Oh.
Where I have the individual pads, positive, negative terminals, and the cutout for the actual LED. So it'll sit halfway in between here, and the two edges will be soldered onto the end. And so I've got, Delta Robotics, the MakerChip 3.0,
cool,
and then the Open Hardware logo.
So and there's some PCB sandwich.
Yeah. So all those layers would be sandwiched together and soldered here on the edge. So the edge plating would actually be the thing holding the PCB together and carrying across signal and power. So these are live. And this one doesn't have my traces on there because I actually was unable to get these vias to work properly in TS Circuit. So I actually had to export this out and work on them in KiCad. But I wanted to show you the actual 3D model here. So I exported the 3D model. Ooh.
What happened? Looks like we were lost stream. Oh well. Yeah. So I guess since I'm guessing that Kevin's battery died or something like that happened. So we might have to go ahead and probably call it for the week and maybe come back and have kind of the finish off the presentation for the PCB MakerChip 3.0 that Kevin was presenting. So there was something in the chat that maybe we could bring up. Dale mentioned that there's Polymakers has a giveaway going, which is interesting. So let's see what that is. Let's see what it is. So yeah, Polypalooza. Okay, so how does it work? Ooh, wow. So yeah, Polymaker is a 3D printer company, right? So that's interesting. Maybe we can find something that we can enter into this competition. That'd be kind of fun. And see what it's doing. Nice. Ooh, 9 days to go. Not a lot of time left. But let's go ahead. Oh, there's Kevin again. You're back.
My computer died.
Okay. Yep. Yeah, I already kind of we can just show next week, the design next week.
All good.
Yeah. So, do you have the kind of a tentative plan when you're going to have the boards back that from that design?
Mm-hmm. Yeah. I can't make any promises right now. There's little tweaks and a little bit of tuning I have to do here and there to make sure the files are actually stable. Because one of my goals was to actually turn it all into a KiCad project that was a little bit more user-friendly or cross-compatible. So my goal this week, next week, is to actually turn all of that into usable KiCad, update the GitHub repo, and have all of that into the actual project before open source. That was my goal, to have this project ready to go and all the information about it cataloged and ready to go. I'm hoping not this weekend, but next weekend. I'm hoping to have everything ready to go. That way everybody gets a chance to take a look at it and try the project themselves if they want to. But for us, we are going to try and actually build the PCB that we've been designing and bring it with us to open source. So
Okay.
if anybody wants to join us in that process, you're more than welcome to ask us some questions, jump in and build it yourself, or anything like that. But yeah, and that includes the PCB, the 3D printing software. I'm sorry, not software, the 3D printing files, the G code, STLs, 3D models, like everything you would need, from the magnets, links to everything. All of it will be pushed up to the GitHub repo and usable, hopefully in
Right.
the next 2 weeks.
100% reproducible from
Yes,
scratch. Cool.
that's the goal.
All right. And for anybody that doesn't know what open source is, I think a lot of our viewers already know. But open source is a kind of a once a year kind of I don't know what you'd call it. It's kind of like a maker fair, but also more of like it has a lot of content creators that come up and they present this huge expo hall. But like I was mostly hallway truck. Last year I was out at the booth with Fixer and just kind of mingling with the crowd. There's a huge component to it, which is like a maker fest kind of thing. And if you're interested, you can just kind of Google open source, but the tickets are like $200. So you kind of you really have to want to go. And I think it's got a big draw. But yeah, there's a lot of people at this thing. If you can see this picture, that's a lot of people. And there's outside there's tents and just creations of all varieties. And inside of the expo like hall, there's the big maker types, content creators. Your Mark Ropers, your backyard scientists, your all the cool guys, right? And yeah, it's a very cool event. I might be going this year. I hope to. I don't know, but that's kind of like the maker chip thing. Kind of was what we're going to bring with us to open source this year, right? So it should be a good time.
Yeah, and I don't work for open source, but I've gone for the last 2 years, and if you have the opportunity, please go. It is a blast. There are so many cool things happening. The conversations. Funny enough, I never actually get to be a part of the keynote sessions because I'm usually running a booth. Yeah. So other members of my team can go on. Like if we have the capacity, usually we're so stinking booked that we're talking to people constantly. And but there's really cool stuff. One year we had a chicken thigh vending machine that you could just get a bucket of chicken thighs, which is actually freaking awesome. There's just some really cool stuff happening up there, and a really great fleet. Probably the best place to meet cool people, in my opinion.
Yeah. So the exhibitors will show up here on this page eventually. On this, you're going to be an exhibitor, right?
Nope. We are a sponsor, actually.
Yeah. Okay.
Yeah. So don't share this with anybody, but
everybody that's live, right?
Well, the first time we applied to have an exhibition, like to have a booth as an exhibitor, but we were technically a business that was doing it. Our project at the time was open source, and we could argue both ways, but they decided that instead of giving us a booth, they would give us a discount on being a startup. Being early and in the process. Like we were one of the first people that reached out and wanted to do something like that. And we've been working with them since we started, and they love having us, and we love going back every single time. And I can't promise that for anybody else, but at least for us, they managed to work with us on finding a really, really reasonable price for us to actually pay for a booth. To help open source itself, because I don't know if you knew this or not, but open source hasn't been profitable yet.
That's not surprising.
For the 3 years that they've done it, it's always been at a loss, and so they really, really trying to really push sponsorships and get cool people and cool sponsors, cool companies to come down there and kind of support the whole event, because it's definitely worth it. So we wanted to be a part of it, and yeah, so we won't be an exhibitor. We'll actually be a sponsor, and we get a couple cool perks. Like we get to meet the other people, the other exhibits, like a day early, like cool little details like that you wouldn't quite get unless you got like a VIP ticket.
Yeah.
But I mean, there's always like spare tickets. If you stick around long enough. I know that there's this spare tickets. So we got a hold of some spare tickets last year, and we gave out a few of them to come to our booth. So there's definitely an opportunity for people to stick around and might get a cool opportunity to go if you can make it down there.
Yeah. So it's at the San Mateo County Event Center this time. Okay. Yeah, I think that there's going to be more info as we get closer to the event. But this is kind of just watch this page. If you have,
Yeah.
like, you should have probably like got the tickets if you wanted to get them a little cheaper. There was like a early bird, right? Like I think it was a bit cheaper, but this is not terrible considering how much is going on there.
No, it's not. They will. I think this is maybe the final price hike that they have on the tickets. There may be one more. I'm not 100% sure. I can't remember, but they will actually open up tickets usually a month after the event ends for next year, and it will be the best price that you're going to get. Like I don't know, 5 times cheaper than the final price is going to be the day of the event.
Yeah, so, I think I got this last time, the premium add-on, and it lets you skip the line, which is nice.
Nice.
Yeah.
So yeah, if you get a chance, definitely check out Open Sauce. If you know about it, stick around. We love Open Sauce. We can't talk about it enough. We've had a ton of great experiences. But if you do make it Open Sauce, come find us. Come check out our booth. We've got some cool stuff to show you, and you'll actually get a chance to see the real maker chip, ideally, in person.
Yes, indeed. All right. So yes, that went pretty well, all considered, even though your computer bit the bucket. But yeah, we got a look at what you're working on. It's a three PCBs kind of stacked together, two thinner PCBs like sandwiched into like a regular sized PCB. That's exactly what you said you were going to do, and it looks like it's come along quite well. I'd like to see the KiCad files so that I can maybe kind of take a look at it, maybe make something of my own.
Yeah.
And we'll keep everybody up to date on that. And of course, if you're watching us, you're going to see kind of the whole process, because I mean, we talk about it like every week. And I'm assuming you got a lot of the other chips, like already made, the magnetic ones.
Yes. I've actually got some variants that I need to ship out to Fixer. He requested some a while back, some hat clips, and I actually ran into some issues with the machines.
Okay.
The UV printing machine that I have spent way too long trying to troubleshoot. So I finally got it. We finally got it back up and running, and ideally I'm going to try to ship out those.
Did you find a good way to coat them so they don't scratch real easy?
Yeah. Actually, I did some more digging, and I found out that there's 3 things. There's 3 ideal ways that you can fix this. Number 1, actually have a thicker coat on the UV. Some versions, like some colors, are a lot more brittle than others. So if you actually do a couple extra layers and a clear coat on top of the layer itself, then it provides a little bit more durability. It's one cohesive component, because UV printing is anisotropic. So it's one solid thing. So if you make it a little bit thicker, durability goes up significantly. Another thing was actually prepping your printing surface a little bit better here. IPA will do it, but some acetone and some more aggressive chemicals to actually clean the surface will help you to improve the surface energy of the plastic, or in my case, PLA and PETG, that makes it easier to print the UV on. And that seemed to make a big improvement. So those two combined, I think I might not have to do any additional step for getting the UV to stick on there for a lot longer than what I had it in. And then the final design was I brought some clear coat acrylic enamel with me, and I just did a couple coats with the enamel, spray paint enamel, and it seemed to do the trick. So those are the three, near-term, low-cost alternatives to kind of improve the overall durability of it.
Yeah, these things are really neat. It would be awesome to have one of these. It's hard to justify it for like a single person, but a makerspace should definitely look into getting these.
So yeah, really I would say that from my experience with Bamboo Labs, I know they're under a lot of heat right now, but they still make really cool, really good printers. Sure. X-Tool, their laser cutters and other equipment. I'm a little bit spoiled here because Eufy makes their Anchor. Anchor is the company behind it. Their design, it's beautiful. It's like, wow, this is actually really stinking cool. But their software is honestly very, very early, very buggy. Oh. I've had a lot of issues and a lot of troubleshooting. It is not nearly as user-friendly as they make it out to be. It looks user-friendly, but there are so many little hidden variables that affect the final output that it's just not, you have no idea. You have to dig through Reddit and find other people having the same problem and figure out, how can you fix it? Yeah. So even then, I would say if anybody is interested in using one of these machines or getting a machine like this, understand that this will take a little bit more TLC. It's a great machine, but you really do have to understand how it works and understand its quirks before getting successful runs out of the machine.
It just looks amazing. Like the prints just look really good, clean.
Yeah, I haven't done anything that big yet. I want to do some textured stuff at some point.
Yeah. Well, yeah, it's like if we can make something and show it off on the show, that'd be cool. I'm assuming you can probably show off some of those chips in the upcoming episodes for people that are interested.
Yes, I'll take some pictures. I'll print a couple extra on hand. Yes.
Awesome. Cool. All right, so I guess that's it for this week. Thanks everybody for joining, and I guess we'll see you next week. If you want to hang out, we are on Discord and devOSH.io. I know some people are already in my local Discord, so I can just talk to them there. Yeah, so we'll see you guys next week. All right.
Bye.
Bye.